Okay, guys, so this is 8.5 chemistry, basically. We have a chemical formula here. This right here is the chemical formula. This right here is called the coefficient. And what this tells us is the number of molecules. Basically, it's saying like C4H6O2, C4H642. It's just, instead of having to say it twice, we can just put that big 2 in front, and it tells us there's 2 molecules of C4H6O2. This number 2 right here is called a subscript. The subscript tells us the number of atoms for whatever it is after. So this tells me that I have 2 oxygens and 6 hydrogens and 4 carbons. Then, of course, we would have to multiply all of these numbers by 2. So here, I'm going to put, it's kind of small to see, but C, H, and O. I'm going to make it a little bit bigger. So I first started with 4, that's my subscript right here, carbons, but I'm going to do it times 2 because of my coefficient. So there's a total of 8. Hydrogens, I have 6 for my subscript, but I'm going to do that times 2 for my coefficient over here again. So that's going to be 12 hydrogens. And then for oxygens, I have got 2 as my coefficient times my 2 subscript, total of 4. So 8 plus 12 plus 4 is a total of 24 atoms. All right, same thing over here. We're going to go ahead and put C is carbon, and I have 10 carbons. Hydrogen is H, and I have 2. Because I don't have any coefficient right here, we just assume that's a 1, so it's like 1 times 10 and 1 times 2, which you know is just the same. O is oxygen, so I've got 2 there, so 10 plus 2 plus 2 is a total of 14 atoms. All right, after this is the same thing as above. So here I'm going to go ahead and just put carbon, hydrogen, and oxygen since we read them the first time. This 4 right here, I've got 4 times my 2 coefficient, total of 8. Now I've got 6 with my subscript times my 2. This 2 goes for everything. Okay, it goes for everything in here. So total of 12. Oxygen, I have got 2 times my 2 coefficient, total of 4. So that is a total of 24 atoms. All right, so just to verify, I had this at 14 and a total of 24 over here. So in order to grid this one, this is a whole number so that it's going to go right here. So guys, you would be surprised to know how many of you guys got the correct answer on the gridables, but did not grid these correctly on your thing. If it is a whole number, it goes to the left of that sign. If you put it over here, it is wrong. Make sure you don't get those wrong.
Okay, here's page 2. How do we find the mass number of an element? Well, we know that all the mass is located where? In the nucleus. Well, what 2 items are in the nucleus? We have the protons and the neutrons inside the nucleus. So to get the mass number, we have to add protons plus the neutrons. Remember, the electrons are out on that shell, and they're so small they have no mass at all. So the mass always comes for the protons and the neutrons inside the nucleus. And now, here we go, some more practice with our counting our elements. Whenever we have one of these problems, the first thing you're going to want to do is list your elements. The first one is Zn. How do I know the N goes with the Z? It's because it's a lowercase letter. Then we have capital S and we have capital O, so we have 3 elements in this compound. Now, in order to count, we have taught you guys to use the 3 questions. First, does it have parentheses? Does it have a subscript? And finally, does it have a coefficient? If the answer is no, then you put a 1. If it's yes, then you put whatever number that is. So this first one, ZN, parentheses, no, so we put a 1. So, does it have a subscript? No, so we put a 1. Does it have a coefficient? Yes, 5, so 1 times 1 times 5 gives us 5 zincs in that particular compound. Second one, S, does it have a parentheses? No. Does it have a subscript? No. Does it have a coefficient? Yes, giving us 5 atoms of sulfur in that compound. Last one is oxygen, parentheses, no. Subscript, yes it does. It has a subscript of 4. Coefficient, yes it's 5. What's 1 times 4 times 5? It is 20. So the total number of atoms is 5 plus 5 plus 20, giving us a total of 30 atoms. Okay, the second one over here, we've got 4Al2, CO3, parentheses, 3. So first step is to list our elements. We've got Al, which is aluminum, C, which is carbon, and O, which is oxygen. The aluminum first, parentheses. There are parentheses, but Al is outside the parentheses, so they don't count, so no parentheses. Subscript, yes, a 2. Coefficient, yes, a 4. 1 times 2 times 4 gives us 8. Carbon, parentheses, yes, 3. Subscript, no, that would be a 1. Coefficient, yes, 4. 3 times 1 times 4 is 12. And finally, oxygen, parentheses, yes. Subscript, yes. Coefficient, yes. 3 times 3 is 9. 9 times 4 is 36. So there are a total of 36 oxygens, and the total number of atoms would be 8 plus 2 is 10, plus 6 is 16. 3 plus 2 is 5, giving us a total of 56 atoms in that compound. All right, the next one up, here we've got Pb, which is lead, N, which is nitrogen, and O, which is oxygen. Our first question, parentheses. No parentheses for the lead. Subscript, that would be a no, and coefficient is a no, giving us just 1 lead atom. Nitrogen, there is a parenthesis, which is a 2. There is no subscript, and there is no coefficient. So that gives us 1 times 1 times 1. Sorry, I messed that up. Giving us 2. 2 times 1 times 1 is 2. And then we have our oxygen. Our oxygen has a parenthesis of 2. It has a subscript of 3 and no coefficient, giving us a total of 6 oxygens. And finally, in this last one over here, we have nitrogen, we have hydrogen, we have Cr, which is chromium, and we have oxygen. We don't quite have enough spaces for you there. Nitrogen, do we have parentheses? Yes, at 2. Do we have a subscript? No, we do not. Do we have a coefficient? Yes, we do, giving us a total of 4 atoms. For the hydrogen, we do have parentheses. It's a 2. We do have a subscript. It is a 4, and we do have a coefficient, which is a 2. 4 times 2 is 8. 8 times 2 is 16. Chromium, no parentheses. The rest of these are outside the parentheses, so chromium has no parentheses, has a subscript of 2, and still has that coefficient of 2, giving us 1 times 2 times 2, a total of 4. And our oxygen, of course, is outside the parentheses, so that would be 1. It does have a subscript of 7 and still has that coefficient of 2, giving us a total of 14 atoms. And if we add all of those together, we get 48 total atoms. 38. Sorry, I cannot hear today. 38. Oh, I forgot to add this one over there. Sorry, guys. And over here, we added the total. We had 6 plus 2 plus 1, giving us a total of 9 atoms. And then down here, now it is time to get our mini assessment. So we're going to pause the video right now. We're going to give you time to go pick up your mini assessment. Make sure that you write your total percentage right here whenever your teacher tells you what your grade is.
All right, guys, so now we're trying to figure out the difference between an element, compound, or mixture. So an element right here, just so we know, is a pure substance. This is something that will be found on the periodic table of elements. A compound is two or more elements combined together. So, combined together. Two or more actually different elements. That is a kind of like a compound word is what I think about, like a butterfly or two different words. But when you combine them together, they become something entirely different. So think of a compound and a compound word, kind of the same. A mixture can be separated. I think of it like Skittles and M&Ms. If I have a mixture of Skittles and M&Ms, can I still easily separate them out? All right, so that being said, let's go through this. Diamond. Diamond is just pure carbon right here. So that is going to be considered carbon as an element. Air. Our air is made up of oxygen, nitrogen, some carbon dioxide, a couple of different things. So that's going to be considered a mixture of different compounds. Krypton is on the periodic table of elements, so it's going to be elements. Water, you're not going to find that on the periodic table of elements. That is going to be a compound. You've got two or more different elements combined together. Same with this one, ammonia. That's going to be a compound. Now wood, a little different. This is several different compounds combined together to make, there's like cellulose in there, there's water, there's something called lectin or something like that. So this is actually considered a mixture. We could, if we wanted to, separate those out. Dry ice, you've got two or more elements combined together, that's going to be a compound. Same with this one, two or more elements combined together, a compound. Two or more elements, compound. This is just bismuth, it's a pure substance, just Bi. Whether there's one Bi or Bi with 200 of them, not that there probably would be, but either way, if it's just Bi, bismuth, it is considered an element, pure substance. Two or more different elements, it's a compound. Two or more different elements, compound. Bronze, this is a mixture of copper and tin. Stronger than copper, stronger than tin, combined together, they are quite a bit stronger. That is a mixture. Baking soda, two or more elements combined together. Uranium, it is just a U, so that is a pure substance, an element. Titanium, just Ti, element. Energy does not fall within any of these, so we're going to put an X, which is, if it's X, none of these. Gold is an element. You'll find it on the periodic table of elements. A dog, or like us, or whatever, we are composed of different things. We've got lots of water in us. We've got some proteins. We've got some fat. We've got some bones. So we are considered a mixture. Iron on the periodic table of elements. And then concrete is a mixture of rock and lime, and not like lime, that kind of lime, but the chemical lime. So that is a mixture. So again, flashback, what two subatomic particles, anytime where we see subatomic particles, our choices are either protons, electrons, or neutrons. That is it. So we're looking for two that make up the mass. The only ones that have any sort of mass are going to be our protons and our neutrons, and each of those have a mass of 1 AMU each.